Now in part B, it says in the Taylor series for f about x equals 2, what is the coefficient of x minus 2 to the 2n? And what this is really asking for is what is the coefficient for the general term, because the general term is going to happen to be x minus 2, involve x minus 2 to the 2n. And actually we did the work for this even though we didn't realize it above. If you notice there, the general term says x minus 2 to the 2n. Well, what is the coefficient? The coefficient of x minus 2 to the 2n is just 1 over 3 to the 2n times 2n. And that is the coefficient of x minus 2 to the 2n for n greater than or equal to 1. And I'm going to guess that the purpose of this part here was to help you find the general term of the expression that you, or of the polynomial that you found above. Now, it is true that the polynomial above actually only is a 6th degree polynomial. So we found it, and I may have mistakenly written this plus dot 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 plus above because we had all of the terms already. So I'm just going to erase that. There were only 4 terms. It's a 6th degree polynomial, and that was it. There's no general term. But if there were, and we wanted to have more terms in that, it would be x minus 2 to the 2n over 3 to the 2n times 2n. The coefficient of x minus 2 to the 2n would be, as I have here, 1 over 3 to the 2n times 2n. In part C, we're asked to find the interval of convergence of the Taylor series for f about x equals 2. Now recall that finding an interval of convergence, and there are 2 ways. One, if it's a geometric series, it will converge when the absolute value of r is less than 1. Otherwise, we'll have to use the ratio test, and we're looking for the limit as n approaches infinity of the absolute value of the n plus first term over the nth term, where that is less than 1. And with the ratio test, don't forget to check the endpoints. Alright, so we're going to start on this journey here. Now for the n plus first term, we're substituting n plus 1 for n. So in the numerator we have x minus 2 to the 2 times n plus 1 quantity, which would be 2 to x minus 2 to the 2n plus 2. Then again in the denominator we have 3 to the 2n. Substituting n plus 1 for n, we're going to get 3 to the 2n plus 2. And 2n is now going to become also 2n plus 2. And instead of dividing, we're going to multiply by the reciprocal of the n plus first term. And we get 3 to the 2n times 2n in the numerator, and x minus 2 to the 2n in the denominator, and that's absolute value. Alright, so to simplify, we put all of our n's together and all of our x's together. And recall, when we're dealing with n's, they're always positive integers, so we don't have to worry about the absolute value with them. We basically have 3 things going on. We have this 3 to the 2n over 3 to the 2n plus 2, and that should just give me 1 over 3 squared. Then I have 2n over 2n plus 2, and the limit of that as n goes to infinity is simply going to be 1. So that goes away. And finally we have, in absolute values, the x minus 2 to the 2n plus 2 over x minus 2 to the 2n, and that's going to give me x minus 2 squared. And I believe because of that x minus 2 is squared, the absolute value is also not necessary there. Since our answer no longer has any n's in it, the final result is x minus 2 to the second power over 9, and we need that to be less than 1. So we need x minus 2 squared less than 9. We can take the square root of both sides. And if you recall that the square root of something squared is the absolute value of that. The square root of x squared is the absolute value of x. And so we end up with x minus 2, absolute value of x minus 2 is less than 3. And so we would get negative 3 is less than x minus 2 is less than 3. Adding 2 to both sides, we would get x is greater than negative 1 and less than 5. We still have to test the endpoints, which we'll do in the next video, and we'll continue it there.